for which the projectile projected up an inclined plane strikes normally again the inclined plane. I'm just bringing that, I'm asking that condition. So what do you mean by this? Okay, let's get the diagram. I'm projecting a body from here. It will describe a trajectory such a way that it will strike the inclined plane here normally. Able to see this? It is in fact perpendicular here, no? At t equals 0, I projected. So let this be alpha. How that angle alpha and theta are related is what? Or what are the conditions? We don't know anything. Okay, let's see what we'll get here. So at point B, it will strike normally. Now we'll resolve G also. This will be G cos theta, G sin theta, G cos theta. Resolve velocity also, U parallel, U perpendicular. Let's get into the calculation. It should strike normally there. That's what the condition is. So first we'll calculate as usual time of flight after some time t. And I think I'll add up this. Okay, that's one. Related to diagram, we have made that sentence. Okay, now get into the thing. What is the displacement perpendicular to incline? Should be 0. This part will calculate here. There should be 0. U perpendicular will be U sin alpha t minus G cos theta by 2. Yeah. T equal to U sin alpha by cos theta. There's an expression for time of flight. Okay, let's, what should be the condition for V parallel? V parallel will become 0, no? At point B, how it will strike normally. So here, yes, you just indicate at least, hope everyone is looking at that symbol. It's striking normally, no? So V parallel must be 0. And in fact, at B, the V is equal to V perpendicular. V parallel is 0. So therefore, along the incline, this is perpendicular to incline what we wrote. Parallel along the incline, or parallel to incline. V parallel equal to U parallel minus G parallel T. This should be 0. U parallel is U cos alpha. G parallel is G sin theta, time of flight, 2U sin alpha by G cos theta. Cot theta equal to 2 tan alpha. U parallel is U cos alpha, no? If it strikes normally, this component of velocity should be 0. If this strikes normally, then what is this component? Should be 0, no? Resolve the resolution of vectors. Two tan theta equal cot alpha. I'm getting different thing here. Oh, okay. This one, cot alpha, 2 tan theta. Yeah. With any speed, if the angle of projection, what is that alpha? Alpha is with respect to incline. Alpha is with respect to incline. Alpha, angle with which the ball is projected with respect to incline. And theta is angle of inclination. If this alpha and theta are related by this equation, it will strike normally. So for any speed, yes, definitely no. We got answer in that way only. Means, sir, what is all possibility here? So how do, if you project a projectile up the incline, what are the possibilities? There are 3 possibilities are there. Altogether, there are 3 possibilities. If you project it, when you project it up the incline, the ball will go and strike like this. Or the ball, when you project it, it will strike normally also. There's the one thing. It may strike in this way also. Possible. Huh? It can happen. Getting the idea? It can happen like this. It may strike horizontal also. One more last, if you project it, it may strike the inclined plane such that the velocity will become horizontal to the ground. So there's a one more possibility. We will bring that here only. You are projecting it such a way that I'll make this inclination a little bit more. I'll project it so that it may look at now it is. It will strike horizontally also. So I think you must be ready for all these conditions. So projectile up the incline can strike normally, can strike horizontally not with respect to incline, with respect to ground. Here perpendicular with respect to incline. or it may strike in this way also, where V parallel will be opposite. It all depends upon the U, alpha, theta, what we adjust.
Sir, what is difference between first and last?
It is having some component of velocity in this way. I will show it. There is a difference, no? How is velocity not horizontal?
Yes, sir.
These are the 4 situations are there. We must analyze all these things one by one. So the perpendicular one is what? I brought it. Everyone, so stand on the steps, inclined plane, you know to search the steps which are there, no, they are the inclined plane. Okay, you stand at the bottom, throw the ball so that will go and strike the upper steps. It'll become projectile up the incline. Stand at the top of the steps, throw the ball in such a way that will go and strike the lower steps, then become projectile down the incline. So analyze all this. So tomorrow what happened, we'll focus more on the numericals. Write it down first, we'll end up the class.